This is a presentation of the Fluency Response and Recovery architecture. In the center of this architecture is the incident. And we want to pivot on the incident to determine first, what are we going to do or how are we going to react to that incident? And then second, how do we get to the point of the incident itself? So an incident is a situation where we have an event that's going to change the security posture. And the type of information we're looking for are things that we can use in our response. And our response is going to be composed of three different things. The first thing is we want to quarantine the device. So we need to know what is the device, and often that means to understand who is the user. We also want to recover that device, and it's not just recovering the device itself, but recovering the business functionality of that device. So having an understanding of, again, what that device is and mapping it to what its function is in our company. And finally, we want to prevent any further activity. This means not only prevent the growth of that attack, which quarantine does, but also to respond to the attack itself to prevent it from having any further damage or any associated attacks. What that means is to filter out things like the bad URLs, the IP addresses, and the hosts, and even the files from entering the network. So how do we get this information? Well, the first thing we need to do is take a look at the incident itself. In order to understand the incident, you have to realize that there's tons of events that are coming in. And the first thing we need to do is validate those events. Once an event is validated, then we announce it as an incident and we scope. And scoping is a key attribute to understanding the event process that really gets ignored in the situation of responders. And that means that instead of just looking at this machine attacked this machine using this vulnerability, to understand that the attack itself is usually for more than one system, requires number of hosts, number of addresses, it has covert channels. And so to understand all the aspects of the attack, that's what scoping is. And that type of information is not in an IDS or an IPS alarm. It requires us to analyze or do what some people call forensics to understand what is the scope of the incident. Now we validate using three different techniques. The first, of course, is that we can get key events and say, hey, this is something we want to take a look at. But often that information doesn't stand by itself. In comes a new technique called validation engines. These are like FireEye, Reversing Labs. It allows us to take the content and evaluate that content along with the key events to validate something's bad. We can also use reputational data. Now that can be associated with the key events, but it's better to use data analytics. What data analytics is the ability to capture all these things and then go ahead and do the analysis against reputation, the analysis of key events, and then superimpose the results from the validation engines. These three ways of looking at data, from the key events that come from your security posture, from the analytics from the metadata, and the engines from the content, allows us to play against each other and be able to validate an event and, more importantly, scope it. So how do we scope it? Scoping comes from a technique of actually grabbing this metadata. If we can actually look at all the attributes going across our network and record them, when we have an incident, we should be able to go back and then using the metadata, performing data analytics, scope the event. During that collection of metadata, we can also collect the artifacts. So we don't have to have artifacts directly tied to something sniffing on the network and analyzing it there. We can leverage another type of device that can grab artifacts and then send it to the engines. We don't want to be sending the artifacts to the analyst and then right mouse clicking to say go to the engine. We want all the artifacts to go into the engines that we're paying for. And finally, we have the security posture generates these key events. Now we can encompass all the analysis and process analysis inside the Fluency analytics. So Fluency can handle billions of events a day as opposed to just millions or 100 millions. And this is an important number because, to tell you the truth, most SIEMs can't handle all the flow data and all the event data. People are turning to Splunk, which doesn't really do real-time analytics and is not designed for security. On top of it, Splunk still has a hard time with all this flow data. So Fluency is really designed for this capability. It's a niche kind of design in its way it handles the data. And that's what makes it so powerful. We can search for a particular IP address or a user or URL in seconds, even though we're scanning billions of events. Now, how can we collect all this metadata? not everybody has a high-end TCP flow collection and analysis capability, so Fluency went ahead and built a sensor that collects both the metadata and the artifacts. And this is pivotal because now what we can do is we can send that data to the data analytics engine. At the same time, we grab artifacts and send those to the validation engines. Again, the key events come in, and now we have a complete system. And the objective of this system really is to reduce the amount of time and also increase the amount of awareness and completeness. All this stuff is automated. The searches don't take 45 minutes to pivot on an IP address, which you will get with a SIM when you have more than 100 million records. It basically can do it under 3 seconds, sometimes under a second. And this means that we can pivot, analyze, and validate very quickly. And so instead of having the 20 to 30 minutes, which Cisco talks about, we can do this analysis within seconds.